Today's lesson is called Graphical Analysis, which is actually the same name as the unit that we're working on. It kind of pulls together the information that we've learned. For the notes today, we're going to use actual homework problems. So the problems that I'm working here are part of your homework assignment. Starting with number 1, they tell us, let f of x be a continuous function. Sketch a possible graph of f of x given the information about f prime of x and f double prime of x in each table. And then they give us 4 different tables that we're supposed to work with. For A, we are given this data here and this information here. Now, f of 2 equals 1 actually tells us a point on the graph of f of x. F of x would have the point 2 for x, 1 for y. So we're always going to want to start with any given points. 2 for x, 1 for y. Plot that point there on the graph. Now, they tell us when x is less than 2, so that means for all values to the left of this point that I've drawn here, the first derivative is positive. That would mean that it has to be increasing. The second derivative is negative, which means it would have to be concave down. So on the left side of that, I'm going to show that from left to right, the graph is increasing, rising, and that it is concave down, so more like an upside down bowl type shape. Then it tells me at x equals 2 that my first derivative is 0, so that means I've reached either a maximum or a minimum, and that my second derivative is negative. So since my second derivative is negative, I'm concave down. That means that it must be a maximum according to the second derivative test. Then for x values greater than 2, I have a negative first derivative, so I'm decreasing, going downward, and a negative second derivative, which also means concave down. So the other side will look very much like the first side. So this graph kind of could look like the parent function, well, a transformed quadratic equation. It kind of resembles the shape of a rainbow. Okay, now on B, what I'd like you to do is pause the video, try it on your own, and then you can check it against mine. And we'll do a lot of that in this particular activity. So, hopefully you've got your graph made now. We have the point 2, 2 to start. So, here's my given point. And I have a positive first derivative, so increasing, negative second derivative, so concave down. This part where x is less than 2 is going to look just the same as it did on the previous example. So nothing too exciting there. Then I'm undefined at x equals 2. What could cause my first and second derivative to be undefined? Well, a sharp corner, a cusp in the graph. So we definitely don't want this to look so round like it did on the last one. Then when x is greater than 2, I have a negative first derivative and a positive second derivative. So that means I'm decreasing, but I'm concave up. So this one is going to go down, but in a concave up fashion. So this one looks kind of like a shark fin. And y'all can probably draw these graphs prettier than me, but just as long as you're getting the increasing, decreasing, and concavity correct, sharp corners, round points, rounded off curves, that'll be good enough. Alright, C. Go ahead and pause the video, try it on your own, and then you can check against mine. We have the point 2, 0, so that's going to be right here on the x-axis. I have, when x is less than 2, negative first derivative and negative second derivative. That means that I am decreasing and concave down. So that means it's going to need to start from above, decrease to that point, and it should be kind of like upside down bowl. Then I'm undefined at x equals 2 again, so I'm thinking this should be a sharp corner at the cusp in the graph. X is greater than 2, I have a positive first derivative, that means I'm increasing, and a negative second derivative, which means concave down. So that's going to go up kind of like that. So this one looks kind of like a, oh, what happened? Seagull. Okay, now pause the video, start D, give it a try on your own. D is probably the most challenging, but it's not too bad. So we'll start with the point 2, 1, right here. And when x is less than 2, I have positive first derivative, positive second derivative. So I'm increasing and concave up. Okay, now I'm undefined here, which in the other two examples where I was undefined at x equals 2, I said that was a sharp corner. That's not always necessarily the case, and the reason we know that's not the case here is because I'm going from positive first derivative to positive first derivative. It's difficult to make a sharp corner when the direction isn't changing on your graph, when you're not going increasing to decreasing or decreasing to increasing. So instead of having a sharp corner or cusp, we would be looking at another way that we could have an undefined derivative, which is a point of vertical tangency. Because it's going to also be positive on the right side of that x equals 2 value, we're going to continue to go up. Oops, I kind of missed the point. And then it's negative second derivative, so it's concave down. Okay, so this point of vertical tangency causes the graph to be undefined at that value. And this one is kind of like a little snake or an S curve almost. So, okay, hopefully you did pretty well on those. The next one we're going to do is number 2. Number 2 says how many critical numbers occur on g of x. Now, g of x is given here. Critical numbers are going to be when the first derivative is equal to 0. So that's going to be anywhere the slope is equal to 0. So that could be right up here, down here, and right here. So g prime of x equals 0 at 3 points on the graph. And it does say to explain. We always want to watch for that because the AP exam requires justification. The slope of the tangent line equals 0 at 3 points. Now, number 3, how many points of inflection occur on g of x? And also explain. So, what are points of inflection? That's places where the curvature changes, right? So if you look, the graph begins concave down, it switches to concave up, then it goes back to concave down. So point of inflection would occur midway between the maximum and the minimum here. So there should be one here, and then midway between the minimum and the maximum here should be about right here. So there are 2 points of inflection. So, and I do need to explain this. I'm going to say the curvature of g of x begins negative, or I could say concave down, then changes to concave up, and finally ends with negative curvature since the curvature changed twice, there are 2 points of inflection. Now, when you describe this, your words may not come out exactly the same as mine, and that's okay. Obviously, we get explanations in different ways from each other. The important thing is to cite the things that you are seeing happening on this graph that tell you the answer to the solution. And it is kind of particular that you give a good, complete justification. Now, if you've got your homework paper in front of you, hopefully you do, on number 4, the problem appears to look like the exact same kind of problem as what we just did here on 2 and 3. But if you look carefully at the graph, it says that it's given the graph of f prime. Here we were just given the graph of the original function. The next one, you're given the graph of the first derivative, which does change how you answer these questions. The questions appear to be the same, pardon me, but they're not, because you're being asked to look from the perspective of analyzing the first derivative graph. So think carefully on that. That might be one you want to try to do before class ends so that you can make sure you're on track with that. Or call up a buddy from home, a study buddy. Okay, number 7. This is the last one we're going to do together, and then I'm going to turn you loose to work on the rest on your own. This one says the graph of the derivative f prime of a continuous function f is shown. So here again we are given the first derivatives graph. So this one will be similar to the problem 4 that we skipped a little bit ago. And so part A says, on what intervals is f increasing or decreasing? And I want you to think about this. How do I know if a function is increasing or decreasing? That's going to be the sign of the first derivative. If the first derivative is positive, f prime greater than 0, then it's increasing. If f prime is less than 0, it's decreasing. So my graph is positive here, then it's negative here, then it switches back to positive here. So where is my graph increasing? And we're just we're going to just say that the graph is what is shown here. So technically, they're going to tell you the domain of this graph, whether it's going to negative infinity, positive infinity, or whether it's on a closed interval, closed off at these boundary lines. It's not clear here, but it's always clear on the AP exam, and I'll make sure that it's clear on your test as well. Quizzes and tests. So let's just say that it goes beyond the graph that's shown, that it does indeed continue forever in both directions. So the graph would be increasing from negative infinity to what x value does it stop increasing at? That point 1. When x is 1, it goes down below the x-axis. And also from 3 to positive infinity. Where is the graph decreasing? That is this middle portion from 1 to 3. And increasing, decreasing, we always use open intervals with the parentheses, no brackets. B. At what x values does f have a local maximum or minimum? Okay, maximums occur when my graph was increasing and switches to decreasing. Minimums occur when it was decreasing and switches to increasing. So, for this particular equation, graph, I have positive first derivative to start, which means I'm increasing. Then I switch to a negative, which means I'm decreasing. So this first 0 of my first derivative graph represents a maximum. So I have a maximum at x equals 1. And I'm going to go ahead and justify this even though it doesn't say to, because I might ask you to on your test. Because f prime of x changes from positive to negative. And this is coming off of your note cards for maximums and minimums. You can always refer back to that if you need help. Then, at this other 0 of my first derivative at x equals 3, I switch from negative to positive. So that means I was decreasing and then I'm increasing. So there's a minimum at x equals 3 because f prime of x changes from negative to positive. Alright, C. On what intervals is f concave upward or concave downward? Okay. Concavity we tell by the second derivative. This is a graph of the first derivative. How do I get information about the second derivative by looking at the graph of the first derivative? Well, I would be looking at the derivative of this graph, which, graphically speaking, is the slope of this graph. So, concave up is going to be when I have a positive slope of f prime, and concave downward is when I have a negative slope of f prime. Okay, so where am I concave up? Where is my slope of this graph positive? Rising. Well, that looks like from about this low point, here, let me switch colors, this low point here, on up, I'm going upward from there on. So I'm concave up, let's just say that's about 2-ish to positive infinity. Again, on the Real AP exam and on my test, they'll give you specifically defined points to use. Sorry for the little bit of inaccuracy on this graph. From 2 to infinity is where I'm concave up, and the reason is because the slope of f prime of x is greater than 0. Now, concave down would be from negative infinity to 2-ish. So from the left side of the graph on down until I reach that lowest point. And that's going to be because the slope of f prime of x is negative. Okay? Now, those are all the ones I want to do with you as notes. So you have the rest of your homework to complete on your own. Hopefully you're understanding these concepts of increasing, decreasing, maxes and mins, concavity, points of inflection, and all of that well enough to be able to interpret them from a graph and from a table without needing an equation to do so. Now, one suggestion that I do want to make when you're given a table is perhaps start by sketching the graph and then answer questions from there, because I find that most students interpret the data more easily in graphical form than tabular form. So start with a table, make your graph, then answer the questions if you're given a table. Good luck!